Hello, it is a pleasure to welcome you for my mathematics session. I am continuing with my probability theory. I have already handled one class in which I have taught the basics. It may be like an introductory session in probability theory. When there was a problem which I have not done, and I will do this today. Now you see that here it is given that a box contains 8 items, out of which, see, there is a box. Here is one box. Here is a box 1. You take it in circle or whatever it is box 1, and if you want you can take it like this. Here is a box 1. Here is box 1, and this box 1 contains 8 items are there, and out of which 3 non-defective, 3 defective. It is 3 non-defective and 3 defective, so the total is 8 balls. And it may be balls or something like that, and it is your box 2 is like this. And here you get 5 items. 2 are defective and 3 non-defective, and the total is 5. Now you are asked to find what is the probability that if a ball is drawn from B1 and B2, a ball is removed from B1 and a ball is removed from B2. The first question is both are negative, both are defective. Say I will put it here. Let D1 defective item from B1. Let D1 denote, I am writing here, I will put it in this way here. B B1. Let D1 denote the defective item from B1. So this implies very well. So this implies probability of D1 is equal to, how many defective materials are there? 3. So 3C1 divided by 8C1 divided by 3. So what is the probability that this one defective item will be removed from the ball, the box B1? So let B2, so let D2 be the defective item from B2. This implies P of probability of D2 is equal to, it is, you see that here it is 2 defective and total 5. So it is 2C1 by 5C1, that is equal to 5. So this is, you see that the probability of removing one defective item from this is 3 by 8 and it is 2 by 5. Now the first question is both are negative, both are defective. You see that here, see here you are asked to find what is the probability that both the items removed are defective. That means probability of both items defective. So what is it equal to? See, in the first case it is nothing but it is P of D1, it is defective. See, D1 is negative. You know what is the meaning of this? D1 is negative. D1, it is negative. See, D1 refers to negative. D1 is negative and also D2 is negative. What is that? D1 is negative and also D2 is negative. Now we want the probability of this. But you see that the negative here, they are two independent events. Independent events. One does not have the influence. See, you are removing one ball from here. It is defective. You remove one ball from the other box. So you see that this taking a defective ball from the box 1 does not influence you to get defectiveness from the defective ball item from the second box. It is not. Both here it is defective, there it need not be defective. Here it is defective, there it can be defective. So you see that one event here does not have an influence on the other. Therefore, we say that the defectiveness coming from B1 and B2 are independent. When two events are independent, that is P of if A and B, right here, A and B are independent, implies P, see, independent, P of A intersection B is equal to P of A into P of B. That means what? A intersection B is null. There is nothing common. It does not null. A does not influence the other. They are independent events. Can you understand? So you see that here P of A intersection B is equal to P of A into P of B. Now here you see that I am applying here P of D1 into P of D2 because D1 and D2 are independent events. They are defective. Taking up a ball is a defective ball is independent event for that particular activity. So you see that this is equal to 3 by 8 into 2 by 5, that is equal to 6 by 40. So what is the probability that this is your question number 1? So you see that the question number 1 is, what is if one ball is removed from both the boxes, what is the probability that both are defective? So I have got here. So okay. Now then we will pause on to the second one. See, let us take the second one. See, one is defective and another is non-defective. That means you see that I told you that they are all independent events. See, here you see that, see, let A be the event of defective item removed from, drawn, I will not say removed, drawn from B1 or B2. You know what is the meaning of this? That is, you take a ball from here and you take a ball from here, the event defective, see, let A be the event of defective item drawn from. So this A refers to the event. What is that event? A is the event of drawing a ball which is defective from B1 or B2. I do not know, but only one it is drawn. So you see that, so it is possible that he is asking one is defective and another is not defective. That means what? Here if you take A, it can be, this event can be D1 and D2 ball. See, this can happen. So this is one way of happening. Okay, and that is one ball, that is one is defective and another is. So you see that here this ball is defective, the other is non-defective. And another R, this one I write R, and D1 is defective and D2 is not, D1 is not. So this D1 and D1 means defective, D1 bar means non-defective, D2 bar means non-defective, D2 means this one. So you see that here I can write this. What is this A? A is the event of defective item drawn from B1 or B2. So you see that this event can be of the form D1 intersection D2. What is the meaning of this? This is defective and the other one is non-defective. So there is one way of that. And another way is the first ball from this need not be defective, but the other is defective. So you see that this and these two are independent events. Try to understand this X event and Y events are independent of each other. See, this does not influence. They do not have anything. They are independent happening. So you see that P of A, this implies P of A is equal to P of D. They are disjoint. Here they are mutually disjoint. This is different and this is different. So you see that this is B of D1 intersection D2 bar plus P of D1 bar intersection D2. So they are mutually disjoint. These two are disjoint events. Here this is defective, non-defective. Here this is defective, this is non-defective. This is non-defective, this is defective. So the two events are disjoint, and when they are disjoint they are given like this. And coming to this, so this is nothing but what? These two are independent. See, one does not influence the other. The first one is defective, the second one is non-defective. That means they are all independent events. So you see that P of D1 into P of D2 bar plus P of D1 bar into P of D2. Because D1 and D2 are independent events. So independent events. Now what do you have here? P of D1. What's your P of D1? 3 by 5. So P of D1 bar is equal to 1 minus 3 by 5, that is equal to 2 by 5. Likewise P of D2 is equal to 3 by 5. P of D2 bar is equal to 2 by 5. So here you see that, sorry, this is 3 by 8. See, I'm sorry, this is 3 by 8. 3 by 8. This is 3 by 8 and this is 1 minus 3 by 8, 5 by 8. And here it is 3 by 5 and this is 2 by 5. So substitute here. So this is equal to P of D1 is 3 by 8 into P of D1 bar, see, P of D2 bar is 2 by 5 plus 5 by 8 into 3 by 5. So this is equal to 6 by 40 plus 15 by 40. So you see that here you get 3 are defective, 3 by 8. So 1 minus 3 by 8 is 5 by 8. 2 are defective. So 2 are defective means here 2 by 5. This is 3 by 5. D1 and D2 bar 3 by 8 into 3 by 5. And 2 by 5 into 5 by 8. So this will be equal to 9 by 40 plus 10 by 40. This is 9. So you see that you are getting it as 19 by 40. So you see that this is your second problem. So this problem is over. I have done this. So this. So what is the answer for this? So one is defective and the other is non-defective. That means what? Either in the first item that you pick from the box 1 can be defective and the other one can be non-defective, or box that you get, you take the first item from B1 need not be defective, non-defective, and the other one is defective. So you see that, and you must understand this I have written here. Let A be the event of a defective drawn from B1 or B2. So A can be written as D1 intersection D2 bar union, either this is true or this is true. And here you see that these two are disjoint events, because here it is defective, it is non-defective. Here it is non-defective and both are disjoint events. When both are disjoint events, mutually exclusive, then probability of this will be equal to, if A and B are mutually exclusive, P of A union B is equal to P of A plus P of B. So you see that here I apply. So P of A is equal to this plus this. So I have used that idea of, if two events are mutually exclusive, then P of A union B is equal to, two events are said to be independent if the happening of one does not influence the other event to happen or not to happen. That is the idea. So if they are independent, that is if two events are independent, A and B, you see that I have given here, if they are independent, P of A intersection B is equal to P of A into P of B. See here, I will write here, if A and B are two independent events, then P of A intersection B is equal to P of B into P of A. This is a very, very important thing that you must understand. So this is what I get. So you see that here. So, and another thing that I want to tell you is, it is an addition rule, in the sense that D1 intersection D2 bar, one is defective and another non-defective. That is one form of taking. That is, you are asked to pick one defective and another is non-defective. This is one way of picking it. Or another way of picking is D1 bar D2. So this is one way of picking and this is another way of picking. So if A and B, and these two are mutually disjoint, okay, one same work are done in two different ways. So the probability is this probability plus that probability. That means what? Probability of this plus probability of this. And here I use this particular aspect of, what is that? If they are independent, these two D1 and D2 bar, they are independent of each other. Therefore I have applied here and I am able to get this value here. So this is your second problem. So this second problem is over. So this is also over. Now let me come to this third one. If one is defective, what is the probability that it has come from the box A? He says that this is, I will call it as from B1. See, I will ask the question, if one is defective, what is the probability that it has come? That means what? The items are taken out, that is one from this, and it is found that one is defective. And the question is, what is the probability that it has come from B1? It has come from B1. That means I will write it here. So what is the question that is asked is, see, what is the question that is asked here is, see, probability of, see, one is defective. That means you are finding a defective. D stands for defectiveness. Here D1 stands for defectiveness in, see, D1 stands for defectiveness in B1 and D2 stands for defectiveness in B2. So we have taken. So let us take, there is a defective material, that is two items are taken and an item is found to be defective. The question is, with this item is defective item that has taken from A, what is its probability? That is the question. So you see that here, let D be the defective item. Let B be defective item. See, or let me call this A be the defective item. Let A be the defective item. Let A be the defective item. That means what? 2 are removed, 1 is found to be defective. So that A is a defective item. The question is, from where? What is the probability that it has come from? B1. Okay. So you see that this is a defective material, and you see that this defectiveness, instead of calling it as B1, what I say is this has come from D. You know what is that I am asking? So how should you read this? The defective material, defectiveness has come from, has been found. There are 2 items that were taken from. Just they have taken one from this, one from this. They have found it to be defective. Now the question is, what is the probability that the defective item has come from B1? That means what? This defective, A is a defective item found, and what is the probability that it has from D1? What is the meaning of D1? D1 is nothing but what? D1 is defective items in B1, and here D2 is defective items from B2. So you see that I am taking it like this. B1 is the defective items from B1 and D2 is the... Now you see that A is, that is 2 items are taken and 1 is found to be defective. That is, okay, now question is that defective item from, what is the probability that it has come from D1? From B1. B1 means what? Come from D1. That is the meaning of that. So you see that, now you see that this is a conditional probability. So this conditional probability is nothing but P of D1 intersection A divided by P of A. So you see that this one, here I have written here, so this is a conditional probability B of D1 slash E. How should you read this? A defectiveness has come. What is the probability that it has come from? D1. D1 means defectiveness in B1. So this is what I have got here. So now let me find, I know what is that. What is this P of A? I have got this P of A. P of A is nothing but, what is P of A? It is called the total probability. See, the meaning is that it can be, see, this defectiveness is, defective element can be from B1 or B2. That is what I have written. I gave a very big explanation on that. It can be D1 intersection D2, or it can be D2 bar, D1 intersection D2 bar, and another possibility is D1 bar intersection D2. So you see that this defectiveness can come only in that way. So you see that this PA refers to this particular value 19/40. Now, so this value is known. So don't worry about this. This value is known. Now what is your D1 intersection A? So this D1 intersection A means, what is the meaning of this? A here refers to this D1, either A, I will write here, A is D1 intersection D2 bar or D1 bar intersection D2. This is the meaning of that. So your A is nothing but what? It is your D1 intersection D2 bar or D1 bar intersection D2. So you see that this is what you get here. Now, so this D1 intersection A, this A refers to here, you see that it is a defectiveness. It is a defectiveness. Now he is asking you, it is coming from what? It is coming from D1. It is coming from D1. That means it is like this. So this defectiveness, so you see that here B1, this is your B1 and this is your B2. This is your defectiveness. Here your defectiveness D1, D2, and you see that this D1, see D1 intersection A is equal to, see D1, what is that? This A refers, it should come only from B1. It should come only from B1. So this D1 intersection A is nothing but, this D1 intersection A is nothing but D1 intersection D2 bar. Can you understand what I am writing here? So you see that this is a defective material, that out of 2 you have found 1, and this D1 is the defective item that are in B1. Therefore, when I write D1 intersection A means it is a defective item. Therefore, here it is D1 and this A, this is nothing but your D2 bar. So this means that it is a defective item only from B1. So you see that. So you see that this is equal to D1 intersection D2 bar and this D1 intersection D2 bar. Therefore, see what is that you get? Therefore, therefore P of D1 intersection A is equal to P of D1 intersection D2 bar. And I told you that they are mutually, that is, they are independent. So you see that this is P of D1 into P of D2 bar. So what is your P of D1? 3 by 8 into what is your P of D2 bar? D2 is nothing but what? D2 is 3 by, see, 2 by 5. See here, I will write here. See, we have written here, see, D2 bar is 3 by 5. D2 bar is 3 by 5. So that is 9 by 40. So this is what you get. So your D1 A is equal to D1 intersection D2 bar. Probability of this is equal to this. They are independent events, therefore 9 by 40. Therefore, what is that you get? Now you call this as 1. So your 1 becomes P of D1 slash A is equal to, what is the value of this D1 intersection A? What is your D1 intersection A? This is equal to this, it is 9 by 40 divided by, what is the value of this? So we will see what is, it is D1 intersection A is D1 D2 bar. D1 is your 3 by 8, I have written here, and this is 3 by 5, 9 by 40. Okay, then what is D1 intersection A? D1 intersection A is nothing but what? D1 intersection A is D1, so this is equal to 9 by 40. What is P of A? P of A is 19 by 40. So you see that using, so you call this as your 1, call this as your 2. See, 9 by 40 divided by 19 by 40, that is equal to, using 1 and 2. So the probability of a defective item is from B1 1 is equal to, so this is the answer. So you see that I have answered all the 3 questions. So here I have got both of them defective and one is not defective, and the last question I have taken, and this is the answer. So you see that I have answered all the 3 questions, and here you must have In the book you will find that simply things would be put, but you must know that these are the very essential understanding about the subject, about the that is independent events, mutually exclusive events. So I have given explanation for all these things. From these things it has come like that. And this one I gave you. Here A stands for the defective. Two are taken, one is defective. So I call that as defective. And what is that? See, we have found the defective element, item. And what is the probability that it has come from what? So you have found that defectiveness. Your question is whether what is the probability that it has come. You can similarly find out what is the probability that it has come from B2 also, in which case what will happen is, instead of this this one, it will be D2 bar intersection D1 bar. That is the only thing difference, and you will get the answer for that. Okay then. So this is about, I have answered this question. Now let me, this was the question which I couldn't answer in my last class for various reasons, and this has been